Oh, thank you. And I would like to thank Heritage Malta and Tony for the invitation and giving me the opportunity to present Enigma at you. Enigma, basically, it's a European-funded project. It has to do with basically safeguarding and protecting the cultural heritage. It's a project it's going to be implemented by 12 partners, and it will last for 3 years. We are at the middle of the project right now. We are at the month 18th. It has 3 implementation phases. The first one is user requirements. The second one is basically the development of all tools. And the third phase is deployment and validation. So we have some objectives. It's the co-design of basically a metric that we call unique authenticity identifier, and basically it's based on what we are talking about today, documenting and digitizing cultural heritage. And everything that we have seen, even photos and orthos and models from under the sea, can help us define some things. Also, after basically doing all the scientific innovation work, we have to do some technical development of the tools, and finally we have to disseminate everything to the public. So what are the major challenges of Enigma? One is how we can authenticate and trace the cultural goods, and that's can be done, must be done basically with a minimum amount of information, and we don't have sufficient authentication. The other thing is that in order to achieve that, we need to search in existing repositories. Currently, there are databases having information about stolen objects. And there are databases that have registered objects. So if something is stolen from a museum, we know that it's registered, it's documented, and we have information. But the most common problem that we might have is when we are coming across objects that are coming from illicit digging or looted places, having objects that we don't have any information about. And that's what we want to try basically to tackle. So the first phase of Enigma has finished, which was the user requirements and the architectural model, and also basically the design and the technical specifications. And that was implemented through Work Package 2. And this is basically the Enigma early technical reference. So we can see the whole architecture. We can see some mock-ups of the tools that we're going to develop. And the core of the whole process and the whole Enigma is data. So what we need is for data to be interoperable and to be in a common standard, because there are a lot of databases coming from museums, databases coming from organizations, but everyone uses their own standard. And they use their own, let's say, codification of the data. So we need to find a way to merge all that in a common data model in order to be able to access the data and basically look into them and try to find the provenance of an object that might come across. So now we are at the first stage of the development. We are finishing the first prototypes, both of the UAI. Also, we are going to use machine learning and AI algorithms in order to be able to harvest data for the internet. And another part of Enigma is dealing with trying to detect the illegal excavation of sites using remote sensing. So we're basically developing algorithms for using available open access satellite data, but once the algorithms are developed, then anyone can use it by, let's say, if there is a large organization that they can buy and acquire very high resolution satellite data, or they can have a government that can fly, let's say, a drone over a long term of time, military drones basically, over areas that they think that they might have illegal excavation. We can also use this data to detect possible sites. And this is basically the different developments and the different tools that we are going to produce. So there are data modeling, 3D reconstruction, co-creation of data platforms. We have decision tools, scenario building engine, and the provenance research tool. And the third phase is basically the deployment, the validation. So now basically we're in the case that we're finishing all the development and basically introducing the first prototype of the Enigma platform, and then we are going to test that in 4 different pilot cases. One has to do with a novel kind of documentation from museum items, because we need to have more information or different kind of information from what is currently being stored. Then is to use that UAI and try to see how we can identify and trace objects that are not registered, that are not in any database, are objects that someone looted from a site or got out from an illegal excavation. Monitor endangered heritage sites using the remote sensing tool, and also we're developing a citizen science or a crowdsourcing tool where citizens that might see something that they consider an illegal digging, or they see a site that they see some distraction, or they suspect that somebody might went there and took something, they can post a picture and some information in an online system. And the fourth pilot basically is validating and evaluating all the tools in a basically operational environment. So here we can see the roadmap for technical challenges. The first challenge is to develop the UAI and the related tools, to develop the Earth observation and GIS tools, to link and use all the existing databases, all the data that are out there, and basically develop the decision support system. And here we can see how the scientific objectives and the technical objectives, which is help each technical challenge to be implemented. So we have the co-design of the UAI, the co-creation and the testing and the validation of these UAI tools, and also the machine learning that can do data harvesting basically in databases available that are open to help us define the provenance of a tool. Also, we want to mitigate these anthropogenic threats by basically using Earth observation and GIS tools, so monitoring sites that we know that we might have problems, so because ministries of culture know of sites that are potentially going to be illegal excavated, or monitoring places of conflict like Ukraine or Syria. So you know that there might be some problems there, you continuously monitor these sites, and when you see something, an alert comes up and pop-ups. And also, what we want to do is use all this data that are gathered from web crawlers or online databases in order to do a metadata analysis and try to link something that we don't know anything about to something that is similar to that, and we have information. And by that way, we can link what a policeman sees at the customs when he finds an object and to a known one. And basically, the challenge 4 is how we are going to implement that and validate it and use it in a basically operational way. So that's part of the advanced decision support and communication platform, the validation, and also the implementation of the different tools and application of Enigma under operational conditions. So this is a short description of basically the pilot case. I'm not going to go through them all. And this is an initial thought about the UAI, and this is why it's crucial to standardize the documentation of data. Because when, let's say, a police officer comes across an object, they can't give any insight about the object. They can see very basic stuff. What's the material, what's the dimensions, if it has an inscription, what type it is, if it's a statue, or if it's a, let's say, a painting, that what's on the painting. The secondary parameters is basically tools that we're going to use, and they're going to be used by archaeologists. They can also enhance that. by content semantics or textual content, or because they have more insight on what they see. What we basically need for the optimum parameters is the 3D representations. And we don't actually need to have the actual 3D of an object, but what we're doing is basically by using 3D objects, we are developing different metrics. And these metrics can be an identification for each object. And metrics like that might include the volume or the complexity or the surface of the object, the weight. So by combining all these different parameters together, we come up with an individual metric for each object that this can be used basically to identify the object. And also we're developing a tool that can give the policeman the opportunity to do a very rough 3D model in 1 or 2 or 3 minutes when he has the object in front of him, and basically correlate that with known objects. But in order to do that, we need 3D information about as many objects as possible. And we don't need access. We are also developing a federated module that can, let's say, access the 3D data, harvest the metrics, which are metrics that they cannot be used to reproduce the object, and use that to do the search. And here's some also mock-ups of the 3D modeling toolbox that we're currently developing. So thank you for your attention, and if you need anything else.